Okay. So yesterday we go through the Docker parts, right? So the introduction of Docker. We created Docker file from scratch. After that, we built and run, right? After we got that container. This is the application container, okay? So this is the, yesterday we go through this part. So uh, this is for a, coming to the Docker or Docker file. The Docker file is actually for creating a single container, okay? So consider there is an application have multiple services, so we need to deploy multiple containers. So that's the use case. So how we will proceed in Docker environment or Docker container? The requirement is deploy multiple containers. For example, we have application, that application have a front end and a back end. Okay, this is a deep database or this is the front end application. Okay, so these two containers are the part of a single application. So we need to deploy two containers. So how we will, deploy using Dockerfile because Dockerfile is only for a single container, right? So in this case, we have to use a tool. The name is Docker Compose. Okay, Docker Compose is it's a tool actually. It's a tool to deploy multiple container. Got it. So for that, after installation of Docker, we need to install this Docker Compose tool. Docker Compose tool. Then we need to write. We are not going to create any Docker file. Okay, in this scenario. So for deploy multiple containers. Okay. For in this case, we need to write up a Docker Compose YAML. This is a YAML file actually. Okay, YAML file is a it's a text file containing our application requirement. Okay, our application metadata. What are the services that including in that specific application? Everything we need to define inside the YAML file. Got it, all of you.
Yes.
So coming to the Docker YAML file syntax, okay, or the format, it's starting with the version of the Docker Compose, okay. Then service. Then we need to define the service name within the service. That means how many containers are how many containers we need to configure. So all these things we need to define under the service. For example, front end. So under the below the service, we need to define front end. That's a service name. Okay. This is service type, and under the service, we need to define a service name. Then after the service name, okay, this is service name. Then we need to define the service image. So for example, it's a Nginx. Okay, front end we are going to use Nginx, then we need to define the image, Docker Hub image here. Okay. So whenever it's starting to build this Docker Compose YAML, it will looking for the official image and pull the image and create the container. Same way, we need to define another service that is backend. So the name of service is backend. Then we need to define the image. So it's a Redis, consider it's a backend Redis application. So this will download the Redis image. Pull the Redis image from official Docker repository. So similar way, we need to define how many services we have. Okay, if we have more than two, then we need to define another service name here, then the image. Got it. Any doubt, anyone? Okay, then we can jump into the lab. Okay. For lab, we need to launch one UCT machine to install Docker and Docker Compose. I will selecting my machine configuration from T2 micro to T2 medium. Okay. This is fine. So I'm launching. Okay. So I successfully log into my machine. So first thing is we need to update package manager. Okay. First we need to install Docker. After updating package manager, it update. Okay. Now we successfully installed Docker PS. Okay, it's working fine. Now our requirement is to deploy multiple applications, right? So we need to use the tool Docker Compose. So we need to install Docker Compose tool as well. Okay. Apt install Docker Compose. So this is a command. Okay. Apt install Docker dash Compose. So Docker Compose also installed. You can check the version. AC 1.2902. So that's fine. Now the requirement is we need to write a Docker Compose YAML and we need to define the services or define the container details, multiple container details inside the Compose file. Okay. So I am going to create a file that is Docker Compose for YAML. YAML stands for YAML. Okay. And hit enter. So here we need to define the Docker Compose, multiple containers details. Okay. So that configuration look like this. Okay. Here you can see that version. Okay. The version here I am using 3.8 that is compatible with the Docker. Then the second thing is here you can see the service. So inside the service, we need to define how many services we are going to use within the YAML file. Okay. So here you can see two services are defined, right? Under the services, one is web and one is Redis. That is a service name actually. And coming to web and Redis service, we can see images that specify for the specific service. Okay. Here we can see the Nginx latest. This is the Docker Hub format. So this is actually Docker Hub image. This will pull the latest Nginx. Nginx is a web server. Okay, we are mostly using web server for our front-end application like that. And this is the first container details, and this is the second container details. So both are we define the same file. And also, if we have more containers, then we need to define below. So this is a simple example. Okay. So here under the image, we need to define the image, then the port number using for the Nginx. Okay. That is 80 is the container port and 88 is the host port. Okay. This is actually a binding. Similar, yesterday we go through the binding part, right? So the first one is host part, second one is container part. So we need to open 8080 to access the Nginx application within the container. So coming to the container, it's open 80. Okay. Then restart. Containers have restart policies. Okay. Restart policies means if our container will facing any issues and go into exit state or any other state, or our host machine rebooted case or any host machine related any issues, our service, the Docker service or the Docker service will go into stop state or any issues. Okay, facing any issues. So in that case, our containers also go into stop state. For example, one of the common example I will tell you, like we install Docker, okay, and we run some containers, okay. So after some time, we stop our machine, the EC2 machine. Then we restart that machine. Okay. So whenever we restart the machine, we can type Docker PS. We can't see any containers because all the containers is stop state. So we need to manually reset each containers. Okay. So if we define the restart policy, then the Docker automatically restart the container. There are different types of reset policies are there. Here you can see the policy defined as always. Always means the container will restart always. Okay, if in that cases, okay, the cases is any issues related to the container and it's going to exit state, then it will automatically restart, or else the our system, okay, the EC2 mission issues like stopping state or restarting, it will automatically start container. Some other policies are there, like we can define no, or we can define unless stop. Some options are there for the restart policies. Okay. So the next service name is Redis, and we need to define the image name for the service, that is Redis latest. This is a database server. Okay. So it will pulling the latest image from Docker Hub, and the restart policies for the same we put it as always. Now this is fine. Though, so this will create a uh, two application. Okay, two application container. Save and exit. Now we need to use, okay, for the Docker Compose case, we need to use Docker Compose commands. For starting the container, we need to type Docker Compose up. So this is a command to upping or starting our containers. Okay. So whenever we typing the Docker Compose up, it will looking for the same working directory for the Docker Compose YAML file. So we need to keep that Compose file in the same directory. And it will taking the YAML file and execute the uh, services, or what are the things we define in the service. Okay, I mean file. Also dash D, so it will run detachable mode. Okay, so hit enter. See, it's starting. It's pulling the latest Nginx image. And next, you can see Redis image. So finally, we can see like this. Okay, creating Ubuntu Web 1 and created Ubuntu Redis 1. Both are done. Now we can type Docker PS to viewing the container. See, both container are running. Anyone have any doubt?
Is there any reason why we took Ubuntu image instead of Linux?
Where?
Whenever we are choosing the EC2 instance, we took the image as Ubuntu.
Which image?
Ubuntu.
You mean base image, right?
Yes.
So here the base image, we are not defining any base image because coming to see here the images we defined, one is Nginx and another one is
Not this
Redis, right?
one. Not this one. Whenever we are creating the instance, EC2
EC2.
instance, yes.
Yeah.
We took Ubuntu image instead of, like, normally we are going with Linux. Right? Today we took Ubuntu image and we have like upgraded to from T2 micro to T2 medium.
Right. So
Is there
that's
any
not
specific reason?
no. Any machines we can use Docker or Docker Compose.
Okay. Why did you go for like T2? Maybe T2 micro won't support this Docker Compose. We have to go with T2 medium.
No. Because coming to T2 micro, that has I mean few resources, right? 1 GB RAM and I think 0.5 core CPU only. So here we are going to deploy multiple containers. So that's why I'm selecting a my medium issue.
That's the reason it won't support like maybe at the whatever the volumes are the space and something it won't
Yes,
support
yes.
for this Docker Compose. So we have gone with T2 medium.
No, no, no. We can run Docker Compose in micro also, T2 micro also, no issue. But sometimes facing some lag or something like that.
Why
Slowly.
didn't we like allocate a port for Redis image?
Hmm.
So will it gonna take by itself if we don't like allocate the port, or how does it gonna work?
Allocate to which? I mean the engineering service, right?
Redis, we have given Nginx 8080 like port is
Oh,
8080 and
yes, 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 yes,
a
yes.
container is 80. Why didn't we allocate for the maybe?
For Redis, right?
Mhm.
For Redis, we are not opening any port actually, because Redis default port number is 6373. See, here we can see. This is a default port number.
379.
6379, yeah. So we don't access Redis directly because it's a database. So if you
Oh,
need to,
oh, okay,
yeah,
okay, okay. Now I got it. Okay, okay.
Which means it's not directly accessible. That's why we didn't specify a port.
yep, yep.
But how does it know how without a port? How does it communicate?
For that, we need to configure the YAML file actually.
Oh, okay.
For the specific application, we need to define everything. So I am trying to open the port number 8080 to access the application. Okay. Okay. See, Nginx is working fine. Got it. So, so this way we deploying multiple containers. Okay, using Docker Compose. So the next thing is using Docker Compose. We can Docker Compose. We can use like load balancer feature as well. Okay, leveraging Nginx load balancer feature. Okay, load balancer. So using the Nginx load balance feature, we can set up the similar type of load balancer using Docker Compose as well. For that, for example, we have a application. Okay, application container. So this is an application container. For same, we have two applications. Okay, identical application, app one and app two. So these are different port. Okay, sorry, container. This is container one, and this is container two. And we install this is a web application, so we install Apache to serving the Apache web content. Okay, for both we install Apache. After that, we keeping our application code. Okay, Apache. So here two Apache, two container, and identical application. And we need to set up a Nginx here. Okay, to configure the load balancer. So we need to install Nginx. and the Nginx belongs to another container. And here we need to configure Nginx configuration. Okay, there is an Nginx configuration file, and we need to define everything. After that, we will provide the Nginx container port number with the EC2 machine. Inside the EC2 machine, actually, these three containers are inside a EC2 machine, right? So we only provide the Nginx port number. Okay, for example, 80 or 81. Okay, define the port number and the EC2 machine public IP. So how the request came, like if anyone accessing our application, our actual application running in a Apache web server, okay. Nginx also a web server with its own some features like we can load balancing, software load balancer there, reverse proxying there. Using Nginx, we can reverse proxy or set up a reverse proxy. So a lot of features in coming to Nginx, okay. So one of the feature is load balancing. We are now taking, okay. So the request now directly hitting to Nginx container. So the Nginx container taking the request and routing that request to the backend servers. So this two servers we called as a backend server, okay. So this is algorithm, default algorithm round robin, okay, round robin. So the second request sending to the second container. Like this, it will work. Good. So similar setup we can do with Docker Compose. Any doubt? All good, right? All of you.
So you can the load balancer can be configured in the Docker Compose.
Yes. One of the service we need to define inside the Docker Compose is Nginx.
Okay, and then Nginx will have a load balancer inside it.
Yes. So we can try to do one lab, okay, similar setup. For that, we need to go to the Docker part, okay, and I will create one direct, okay, keeping that file configuration. Now here we need to create a Docker Compose file. So here we need to define the load balancer configuration. So it's look like this, okay. So here you can see we have different services. App 1 is one of the service, App 2 is another service, and Nginx is another service. Also here you can see the volume part. Okay, I will explain the volume later. For the Docker volume, Docker network, I will take another section. Okay. So here for the App 1, you can see the image we define is Apache HTTPD. So the App 2, same. We are going to create another HTTP service for the second container. And for the third container, that is we name as Nginx and we define the Nginx image. Okay. For the Nginx, we are opening the port number 80 in the host part, and default port number for Nginx is 80 actually. Okay. So that's we binding here with the host easy to mission 80 port. Only for the Nginx. Okay. The rest of them you can see we did mapping it here above. And one more thing here, we can see the volume. Volume is actually Docker volumes. Okay. So volume is it's nothing actually. For example, this is a EC2 machine. Okay. EC2. And inside the EC2, we install the Docker and everything, right? So we finally we install the container, right? Like here. Okay. So I will, this is a container. Okay. Inside the EC2. So I will write it here as well. This is a container. And for example, some containers, okay, needs a separate storage space. Okay, for example, we are actually defining these things. So, for example, it's a database container, DB database. Consider there's a database container running. So we need to set up the data is persistent. For persistent data, we need to create a separate volume in our EC2 machine. Okay, separate volume in EC2, and after that we need to mount that volume. Okay, we call as volume mounting. Mount that EC2 machine volume with the container path. So this is the volume name, and the format is volume name, then the path of our path or directory of the container. Okay, for example, inside container, okay, our all the application data will be in a app directory, consider like that. Okay, so whenever we log into the container and we type /app directly, we can see our all the files or database file or whatever, all these persistent data, or yeah, all the files are belongs to the path application. Okay, -app. So if the container is stopped, okay, for example, if the container is removed or deleted, our data will lose if we do not set up the persistent data or the volume setup. Okay, so actually coming to the automation part, okay, whenever we starting a container without volume, that specific container data will be in our EC2 machine directory. Okay, so there is a directory like Docker volume, I think something like that. There's a directory there. So under the directory, we can see the temporary data. For this container, we can see the temporary data. So if we stop or if we delete the container, this temporary data will gone. So we need a dedicated data. So that we need to create a Docker volume actually. So we need to first create a Docker volume from scratch. Docker volume using command. Okay, Docker command. Docker volume create. Sorry. Yes, Docker create volume, then the volume name. So we can see the volume in the EC2 machine. So then we need to mount that volume whenever we starting the container. Actually, Docker run command. Then we can define the mount path as well using the -v flag. -v. This is a command actually. Docker run. So we have a Docker image here. Okay, consider like that. So this is for the Docker case. Okay. So we need to use -v flag. Then we need to define the volume that we created and keep in this EC2 machine like my volume. Then we need to mount. Actually, we are going to mount with the container path. Okay. Then we need to define the same path. App. This is a container path. So that's fine. Then we need to define the image name like that. Okay. So what will happen whenever the container starting to, taking the data or some data are there, okay, in this directory. So all that data belongs to the EC2 mission Y volume. We can see that data as well. So the container will stop, don't worry, or container will delete, don't worry. All the data belongs to our EC2 mission Y volume. Also, we can attach this volume to another container as well. So that's the volume part actually. So coming to the lab, I will show you, okay, coming days, how to create volume and mounting. So in this case, you can see in the Docker Compose, there is a volume creating, okay. So coming to YAML file, we can define volume, okay, and we need to define the name as well. So here you can see, this is the host mission volume actually, Nginx configuration. And this is mounting, okay, this is a mounting way, and this mounting to the container path. So this is a container path actually inside container. So as of now, we didn't create any file here, okay. So we need to create a file and we need to put the Nginx configuration file actually. So this configuration file passing from the local machine to the container machine configuration file, configuration path. So I'm going to save and exit. So one more thing I need to write, that is the configuration file, nano nginx.conf. Hit enter. So the Nginx configuration, inside Nginx configuration file, we need to define the load balancer and everything, okay. So this is a simple format, okay, for this specific lab. So the configuration starting with the different blocks actually, okay. So the event block, then HTTP block, and the server block. 3 block we can see. For the event, we did not define anything. So coming to the HTTP, we can see the upstream server we need to define, okay, upstream. So upstream we name as backend. That means we are now talking with the Nginx. We have a upstream server and the name is backend. And under that upstream server backend, when open the curly, we need to define the servers, the backend servers. So the two servers are there. One is the app1 container for Apache with the port number. Second application container with the 80. That means we created 2 containers, right? We are not creating, we are going to create. So whenever we're creating this configuration file, also looking for the container actually, app1 and app2. This is a service we define in the compose file, app1 and app2. Good. So app1 and app2 is for Apache, is for Apache image actually. And the Apache image is open port number 80 for accessing for the Nginx, okay. Then this is a server block. Here we need to define the port number that we are going to use for the Nginx, that is 80. Then under the location, we can see the proxy pass. So proxy pass is actually the load balancing type, okay, where it's going to passing the incoming request. So that here you can see HTTP backend. That means this backend, including these 2 services, app1 and app2. So this is a basic configuration, Nginx configuration for a proxy, okay, sorry, load balancing. Everything seems fine. Now we are going to, here you can see 2 files are there. Now we are going to Docker Compose, type Docker Compose up. It's complete, okay, Docker PS. See, app1, there app2, and the Nginx 3 containers is up and running. And how we will access in Nginx? Using the port number 80. Okay, so anyone can access our application, that is 00, that is binding with the port number 80. For the Apache, you can see we can't access the Apache web server actually, okay, because only that Nginx is exposing. But the Nginx can access these two Apache applications. Now I am opening one more port, that is for the 80. So the requirement is whenever I am trying to access that EC2 mission public IP with the 80, the requirement is we need to see. So here you can see the 8080, we can see the Nginx. Okay, so the same way I'm using 80, I can see the Apache application. See, it works. It's actually routing. Okay, whenever we refreshing, it's taking another. In this case, two HTTP servers are there, right? So we can do something. Okay, like we need to log into the one of the container and we can change the code. So I am logging to one container. Okay, VXT IT interactive mode. Then the container name new app 2.1. Then open in a bash in bash. So it will open the shell. Okay, see now we are logging to the container actually. Not easy to mission. Okay, inside container. So here we can see ls, we can see the directory as well, the minimal directory. So most probably this application index.html file, the hd docs file. Okay, so cd hd docs ls. Yeah, see the index.html file there. You can cat. I don't know the cat is working inside this minimal version. Otherwise, we need to install. Okay. Yeah, cat is working. See, this is the content application content. It works. So same we can here see here. Okay. And now I am going to edit nano index.html file. See, nano is not here. Okay, so we need to install nano apt install nano package nano as no installation candidate. Sometimes we are facing similar type issues. Okay, in that case, we need to try to update the package manager. So it will mostly resolve the issue. apt update,
Or you could try using Vim
right?
or Emacs.
Yes. See, I updated. Now I am trying to install. Yeah, now it started working. Now I will open with the nano. Save and exit. That's fine. Okay, now I am going to refresh here. So we can check the load balancer is working or not. See, this is one of the container and I have refreshed. This is another container. Got it. So load balancer is this offshore level load balancer, Nginx load balancer is working fine. Got it, all of you.
Yes.
So anyone have any doubt?
No, not me at least. I'm good.
Okay.
Yeah. When I like When the class is going on, it is fine. But if we won't practice, it's like new stuff for me. Until and unless I practice, it would be great if you can provide the videos so that I can practice.
Today I will share. Okay, I talked with the Poonam yesterday.
Okay.
So hope it will. I can share today. Okay.
Okay.
Okay. I'm just trying to take some sample HTML code. Okay. It works actually. So anyone have a doubt? All good, right?
Yeah. Tomorrow, can you explain with the example taking from like source code, source version control system, and pulling it from there rather than like on the web app?
You mean CACD, right?
Not the CSD. Then we can do this from the
Okay,
source
okay.
code.
Okay, got it. And yeah, we can do that. Okay. So we can deploy some sample application, right? Like Node.js or Python.
Whatever. Yeah.
Yeah, we will do that. So we can wind up, right? Today's section, all of you.
Sure. Thank you for the class. Have a good morning, good night to everybody here.
Bye. Meet
Bye.
tomorrow.
Bye.
Yeah.
Thank
Bye.
you. See you tomorrow.
Yeah.